Looking up at the night sky has inspired humans for centuries. Long before rockets existed, people imagined leaving Earth to explore the cosmos. In the 17th century, for instance, writer Cyrano de Bergerac wrote satirical stories about traveling to the moon and sun. By the 19th century, science fiction pioneers like Jules Verne and H.G. Wells were weaving tales of space travel grounded in the scientific knowledge of their time. These early dreamers set the stage for real-world space exploration. In this video, we'll journey from those first imaginative visions to the latest cutting-edge rockets. Each milestone, from the first rockets and satellites to moon landings and Mars rovers, built the technology that carries us to the stars. Early visions and rocket pioneers. Humanity's path to the stars began with imagination and early experiments. Centuries ago, observers of the heavens dreamed of venturing into space. But turning those dreams into reality required new technology, namely rockets. The first person to seriously study rockets for spaceflight was a Russian schoolteacher, Konstantin Tsiolkovsky. In 1903, he published an article outlining how rockets could reach orbit, laying out many principles of spaceflight, like the famous rocket equation. Tsiolkovsky never built a rocket himself, but his ideas inspired others in Europe and the Soviet Union. Across the ocean, American physicist Robert Goddard was also intrigued by space travel. In 1926, Goddard built and launched the world's first liquid-fueled rocket, a small missile that flew for 2.5 seconds and reached about 12.5 meters high. It wasn't much by today's standards, but it proved rockets could work. Goddard's experiments, funded partly by the Smithsonian, were initially ridiculed. A 1920 New York Times editorial even mocked the idea of rockets working in a vacuum, only to print a retraction in 1969 after Apollo 11 launched. Meanwhile, in Europe, Hermann Oberth published influential books in the 1920s on rocketry and space travel, inspiring rocket enthusiast societies in Germany. A young Wernher von Braun was among Oberth's followers, dreaming of building rockets to reach other planets. These pioneers, Tsiolkovsky, Goddard, Oberth, and others, provided the theoretical and experimental foundation for the space age to come. Rockets in war and the dawn of the space-age rocket technology took a leap forward during World War II, unfortunately, as weapons. Nazi Germany developed the V-2, the first long-range guided ballistic missile. In 1944-45, V-2 rockets bombarded London, reaching altitudes of approximately 60 miles, nearly 100 kilometers, and speeds over 3,500 miles per hour. The V-2 was the first man-made object to cross the edge of space, the Kármán line, though it was used for destruction. When World War II ended, the United States and the Soviet Union eagerly seized German rocket know-how and personnel. Wernher von Braun, the V-2's chief designer, surrendered to the Americans and moved to the US, while the Soviets captured other German engineers and hardware. Both superpowers started building their own rockets, initially for military purposes as intercontinental ballistic missiles, ICBMs. These powerful ICBMs had the range and thrust that could be repurposed to launch objects or people into orbit. The Cold War thus set the stage for a space race. Each side hoped that spectacular achievements in space would prove technological superiority and win global prestige. It all began on October 4, 1957, when the Soviet Union stunned the world by launching Sputnik 1, the first artificial satellite. Many in the West had doubted the USSR could beat America to space, so Sputnik's sudden success came as a shock. This beach ball-sized satellite transmitted simple radio beeps as it orbited Earth every 96 minutes. Those beeps were heard around the globe, an audible proof that humanity had entered the space age. In response, the United States accelerated its own program and, after some early failures, launched its first satellite, Explorer 1, on January 31, 1958, Explorer 1 carried scientific instruments and led to the discovery of the Van Allen radiation belts around Earth, showing that even the earliest satellites taught us valuable new information. In 1958, the U.S. created a new agency, NASA, National Aeronautics and Space Administration, to consolidate its space efforts. But the Soviets kept the lead in these early years. On April 12, 1961, Soviet cosmonaut Yuri Gagarin became the first human in space, completing an orbit of Earth in his Vostok 1 capsule and landing safely after 108 minutes aloft. Gagarin's achievement, a single orbit at about 327 kilometers of altitude, made him an international hero. The United States followed less than a month later by launching astronaut Alan Shepard on a 15-minute suborbital flight. He went up and came back down without orbiting. The U.S. would not put a man into orbit until February 20, 1962, when John Glenn rode Friendship 7 around Earth 3 times. The space race was in full swing, with firsts from each side capturing the world's attention. During the 1960s, the Soviet Union scored an impressive list of space firsts. The first woman, Valentina Tereshkova, flew to space in 1963. The first multi-person crew, Voskhod 1 in 1964, and the first spacewalk by Alexei Leonov in March 1965, all were Soviet triumphs. The United States, for its part, achieved the first rendezvous of 2 spacecraft, Gemini 6 and 7 in late 1965, and demonstrated spacewalking and week-long missions during the Gemini program. Crucial steps toward the moon. The race to the moon. By the early 1960s, reaching the moon had become the ultimate prize of the space race. In May 1961, U.S. President John F. Kennedy boldly declared, "I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to Earth." This challenge gave NASA's Apollo program a clear goal and a deadline. The project was massive and risky. NASA had to develop a new heavy-lift rocket, the Saturn V, lunar landers, space navigation techniques, and life support for week-long missions. Meanwhile, the Soviets secretly pursued their own moon program, but struggled with the huge N-1 rocket and the loss of their chief designer, Sergei Korolev, who died in 1966. After years of preparation and several tragedy as well, including the Apollo 1 fire in 1967, NASA triumphed in December 1968 with Apollo 8 orbiting the moon, and then the big moment, Apollo 11. On July 20, 1969, astronauts Neil Armstrong and Buzz Aldrin descended to the lunar surface while Michael Collins orbited above. Armstrong stepped off the Eagle lander and declared, "One small step for a man, one giant leap for mankind," as he became the first human to walk on the moon. They planted a flag, collected moon rocks, and proved Kennedy's dream was achievable. Between 1969 and 1972, NASA sent a total of 6 Apollo missions to land on the moon, exploring different lunar areas and bringing back scientific samples. The Apollo program's finale in December 1972, Apollo 17, marked the last time humans have traveled beyond low Earth orbit to date. The Soviet Union never landed cosmonauts on the moon, but they did achieve impressive unmanned missions, like Luna 2 hitting the moon in 1959, Luna 9 soft landing and sending photos in 1966, and robotic sample returns in the 1970s. By the late 1960s, it was clear the U.S. would win the moon race. This shift led to a cooling of the competition and a move toward cooperation. In July 1975, American Apollo and Soviet Soyuz spacecraft docked together in orbit for the Apollo-Soyuz test project, a symbolic end to the space race where Cold War rivals literally reached out and shook hands in space. The space race had spurred incredible technological progress in just a decade, from tiny Sputnik to footprints on the moon. Now a new era was beginning. focused on longer missions and collaboration. Space stations, shuttles, and international cooperation. With Apollo over, the 1970s saw a shift towards space stations, living and working in space for longer periods. The Soviet Union led the way by launching the world's first space station, Salyut-1, in 1971. Over the next decade, the Soviets flew a series of Salyut stations, learning how to keep crews in orbit for months at a time. The United States launched its own station, Skylab, in 1973. Skylab hosted 3 crew missions and demonstrated solar observations and microgravity experiments. By the end of the decade, the Soviets had plans for a new, bigger station named Mir, which would eventually launch in 1986 and be continuously occupied for years. Another huge change in this era was the development of reusable spacecraft. On April 12, 1981, 20 years to the day after Gagarin's flight, NASA launched the first space shuttle, Columbia. The space shuttle was like nothing before, a winged orbiter that took off on a rocket stack and glided back to Earth like an airplane, designed to be reused for dozens of missions. The shuttle fleet, Columbia, Challenger, Discovery, Atlantis, and Endeavour, became the backbone of U.S. spaceflight for the next 3 decades. Shuttles launched satellites, interplanetary probes like Galileo, which journeyed to Jupiter, the Hubble Space Telescope, and carried microgravity research labs like Spacelab. Meanwhile, the 1980s saw a boom in satellite technology. Satellites began delivering television signals, enabling GPS navigation, and monitoring Earth's weather and environment, proving that space technology had real-world benefits on Earth. The shuttle program reached great heights, but also faced devastating setbacks. On January 28, 1986, Challenger broke apart just 73 seconds after launch, killing all 7 crew members, including teacher Krista McAuliffe. The tragedy stunned the world and grounded the shuttle fleet for nearly 3 years. NASA eventually resumed flights, but disaster struck again on February 1, 2003, when Columbia disintegrated during re-entry, once again claiming 7 lives. These events were stark reminders that spaceflight remained dangerous. Despite the risks, the shuttle program accomplished remarkable feats, most notably assembling the International Space Station, ISS, in the late 1990s and 2000s. The program concluded with the final flight of Atlantis in July 2011. Over 30 years, the shuttle fleet had completed 135 missions, shaping a new era of human space exploration. From first steps to giant leaps, humanity's journey to the stars has only just begun. Stay tuned for Part 2, where the next era of space exploration unfolds.